In our previous lesson, we learned how to rationalize sets with 1 monomial denominator and then 2 binomial denominator. In this lesson, we want to learn how to solve radical equations. Our objective, by the end of the lesson, you will be able to solve radical equations with ease. Now, to solve a radical equation, 1, you need to isolate a radical term. 2, we square both sides. 3, we solve the new equation. And 4, we check all possible solutions in the new equation. But before we go on, let us remind or learn one simple way of expanding an expression. Given a perfect squared expression like a plus b squared, how do we expand this with ease? That's very simple. This becomes, pick the first term, square it, because it is plus, this 2, write that, then multiply the first term and the second term. That will be a times b. Then plus, pick the second term, square it. I go over again. If you have a plus b, that is first term plus second term, all squared, how do we expand it with ease? Very simple. Pick the first item here, square it, because there is square, plus, because there is plus here. Pick the 2, multiply the first term and the second term. A times b, we get ab. Then plus again, pick the second term, whatever is here, square it. Let's look at this one too. The same way, pick the first term, square it. It's minus, so minus 2, multiply the first and the second, ab, plus, pick the second term, b, and square it. That was quite simple. Let's try on this one. One minus root 2 squared. Pick the first one, 1. Square it is minus. Pick the, write this 2. Multiply the first and the second, plus, pick the second one and square it. This becomes 1 squared is 1, minus 2 times 1 is 2. 2 times root 2 is 2 root 2, plus root 2 squared is 2. We can then say that this is rational, this is rational. 1 plus 2. Then minus irrational, 2 root 2. This becomes 3 minus 2 root 2. We can verify this on our calculator. Now let's take an example on the radical equation. Solve x minus 5 is equal to square root of x plus 7. So 1. Is this an equation? Yes. Why? It contains the equal to sign. 2. Is it a radical equation? Yes. Why? It contains the radical sign. Let's solve it. 1. We need to isolate the term with the radical sign. By inspection, okay, it's already isolated. This is to the right, whilst these ones are to the left. So this is isolated. 2. Square both sides. So I pick the left-hand side. I have x minus 5. Put it together and square is equal to, I pick the right-hand side and square. Expand both sides and simplify. Look at this one. We have x minus 5 all squared. It goes back to a minus b all squared. How do we do that? Pick the first one, square it, minus 2 times, multiply the first and the second, then plus, pick the second one and square it. So we use the same thing here. The first one is x, square it. There is minus, minus, bring the 2 down, 2. Multiply first and second, so x times 5 is x times 5. Then plus, pick the second one, 5, square it. This will be equal to, we know what happens when we square a third. This divides this, and we have our x plus 7. Let us continue to simplify. This becomes x squared. Now watch here. We have 2 times x times 5. 2 times 5 is 10. Then x is x. Then plus 5 squared is 25. This is equal to x plus 7. What we do from here is to transpose x plus 7 to the left-hand side. Why? We want to arrange group-like terms and solve the resulting equation. So I have x squared minus 10x, transposing positive x, it becomes negative x plus 25. I'm transposing plus 7, it becomes minus 7. What happens is that the whole right-hand side reduces to 0. This becomes x squared minus like terms, 11x plus 25 minus this, we can reduce this one, 25 minus 7 becomes 18 is equal to 0. This results in the formation of a quadratic equation, which we can easily solve with our calculator. Now we have x squared minus 11x plus 18 is equal to 0 to solve. There are so many ways to solve this resulting quadratic equation, but one of the ways is by factorization, which will be extensively taught in subsequent topics. But for now, we're going to look for 2 factors of 18, which when we multiply, we should obviously get 18, and when we add, we should get negative 11. And so for 18, we can have 2 times 9. 2 times 9 is 18. And 2 plus 9 is 11. Yet, this is negative 11. Well, when we negate the 9 and the 2, we would get negative 9, negative 2. Amazing. So negative 9 times negative 2 gives us positive 18. Negative 9 plus negative 2 gives us negative 11. That's great. So we pick these ones, rewrite our x squared, and express this particular term, minus 11x, in terms of minus 9 and minus 2. So that will be minus 9x minus 2x plus 18 is equal to 0. Now this equation is actually equal to this. This is your x squared. This is your minus 11x, and this is your 18. The next thing to do is to factorize. So we pick the first and the second term. What is common is xx. So x is common. When x divides this x squared, you get x. And when x divides minus 9x, you get minus 9. Watch. X times x, x squared. X times minus 9, minus 9x. And we come to this one. Minus 2 is common because 2 can divide 2 and 2 can divide 18. We open this bracket. When negative 2 divides negative 2x, it will divide this one, you have x left. And when negative 2 divides positive 18, that will give you a negative 9. That's equal to 0. At this point of factorization, remember your guide. What you have in the first bracket should always be equal to what you have in your second bracket. Then we go on to bring the outside expressions into one bracket. X is outside here, minus 2 is outside here. Then we repeat one of the brackets. X minus 9 is equal to 0. Now when we get here, what is the concept? I have two brackets, this and this, multiplying. But the result, the product is 0. In mathematics, if your product is 0, it means just one thing. Then the numbers involved, one of them should be 0. So if this bracket times this bracket is given as 0, it simply means one of the brackets must be 0. How do we identify that? So we ask ourselves these questions. Question 1. What will make the first bracket 0? It is only when x is equal to 2. When x is equal to 2, 2 minus 2 gives you 0. Or what will make the second bracket be 0? It is only when x is equal to 9. So we've gotten two possible solutions. Two possible solutions. That is x being equal to 2 or x being equal to 9. They are possible because we need to verify. So the fourth step says that verify your answers. How do we verify? Now let's find out if x can actually be 2. We pick this 2, go to the original equation given, plug in 2, 2, 2. Let's see. 2 minus 5 will give us minus 3. 2 plus 5 gives us 9. Now the square root of 9 is actually 3. Let's verify with this one. 9. So watch. The left-hand side gives us minus 3. The right-hand side is giving us 3. So minus 3 is not equal to 3. We'll come back and make a decision. Let's go and verify with when x is equal to 9. We do the same thing. When I plug in 9 and I plug in 9 here, 9 minus 5, I get a positive 4. 9 plus 7 gives us 16. The square root of 16 is also positive 4. So it means 4 is equal to 4. Therefore, the answer that goes with the original equation is x equal to 9. I hope that was quite simple. This brings us to the end of this lesson. In this lesson, we looked at how to solve a radical equation, simply an equation that involves the radical sign. And we looked at the various steps in details. Hope you got it. In our next lesson,